Hello, welcome to the presentation about automated visualization of funding dispersion. This was my project for Smart India Hackathon 2017, under Ministry of Rural Development. My problem statement is real-time visualization of location-wise financial transactions, volume and amount, for various schemes such as PMAY, Gramin, MGNREGS, PMGSY, NRLM, DDU, GKY. As part of various rural development schemes, financial support is provided to beneficiary in which funds are transferred to various beneficiaries. Some locations or areas have high transactions, volume, amount, and some have low financial transactions recorded. An automated system is required which can act as repository for all information and visualize location-wise transactions happening. This would help the MORD, DFS, bank/FIS etc., participating stakeholders in schemes, to visualize the level of transactional load area-wise and help them in making location-specific decisions, such as installing branches, ATMs, BCS in areas with low penetration having large transaction volumes. Let's look at the algorithm. In this algorithm we first find the work done by the employees in the month, then we find work which should have been done, then we compare them both by using comparison factor K. The total work done can be defined as summation of work done for all banks present in that area. Work done for individual bank can be defined as ratio of product of area and number of beneficiaries to product of number of employees and total working hours. Once the total work done is found, work which should have been done can be defined as ratio of number of beneficiaries to number of banks in that area. The comparison factor, K, can be defined as inverse of work which should have been done. When total work done is divided by comparison factor, we get load on the banks in that particular area. Let's look at the example of village name Technopur. Technopur is divided into 4 sectors, 3 of these sectors have financial institutions. According to my algorithm, the stress for particular area is calculated. So let's apply the algorithm to Technopur. Here is the data for particular month, in which for 15 days the banks were open is given, for bank in sector 1, 2, 3 respectively. For example, if we look at the first column, we can understand that on date 1 of that month 2 beneficiaries came, on day 3, 2 beneficiaries came, and so on. When we put values in the formulae discussed earlier in the algorithm, we get the load as 489.2. The law states that, in the end of the month, when each beneficiary is paid, the load should be 0, let's call it as a state of excellence. To achieve the state of excellence, the bank employees had to work 489.2 units more than what they were supposed to. Working this much is not much for the employees, but when this value goes above 500, it becomes inhumane, and there must be a financial institution open to balance the load. Keep in mind that, the threshold, which is considered as 500 in this case, can be defined by the authority and can change from place to place. Let's go back to Technopur. Remember, in previous calculations we did not consider the sector 4, and beneficiaries living in it. Let's consider them now. Let's divide the sector 4 in 2 equal halves. People from half near to sector 1 will go to sector 1 bank, and people from half near to sector 3 will go to sector 3 bank. Now let's calculate the load. When we consider the sector 4, we can see that the area and number of beneficiaries are changed. After the calculation we can clearly see that, the previous load is increased, and it's become 861.83, which is fairly larger than the threshold, which is 500. Hence we can clearly see that there needs to be a financial institution present in sector 4, to balance off the load.